So far, we have concentrated on whether we can develop AI, but we must also consider whether we should. If the effects of AI technology are more likely to be negative than positive, then it would be the more responsibility of workers in the field to redirect their research. Many new technologies have unintended negative side effects. Nuclear fission brought Chernobyl and the threat of global destruction. The internal combustion engine brought air pollution, global warming, and the paving over of paradise. In a sense, automobiles are the robots that have conquered the world by making themselves indispensable. All scientists and engineers face ethical considerations of how they should act on the job, what projects should or should not be done, and how they should be handled. See, for example, the Handbook on the Ethics of Computing. AI, however, seems to pose some fresh problems beyond that of, say, building bridges that don't fall down, such as people might lose their jobs to automation. People might have too much or too little leisure time. People might lose their sense of feeling and being unique. AI systems might be used towards undesirable ends. The use of AI systems might result in a loss of accountability. And lastly, the success of AI might mean the end of the human race. Tonight, we will look at several of these.
The program you are about to hear is fiction, science fiction. We make no guarantees, however, how long it will remain fiction, fiction, fiction.
Self-sufficient salutation, Cognonox. Welcome to Exofathom, the show where we dare to explore breaking reality. I'm your host tonight. I'm Mike, and always joined with my two lovely co-hosts, Nick and Ayla. Nick, how's it going?
Hey, happy Monday. I'm well. How are you?
Oh, it's Monday.
It is.
Monday. But it's an all right Monday.
Okay.
Ayla, how you doing?
I'm feeling really daring today. Talk about some stuff and think about some stuff. Yeah.
Outside of King Arthur?
Yes. To those of you listening, I was quite cozy prior to this recording. You ever forget that you were going to do something or the time shift or something? We just did an episode on time travel, so I'm convinced time isn't real and such it's been chaos since. And anyway, yes, I was watching King Arthur and it was fabulous.
And I messed it all up. It's like, hurry up. We got to get the show going.
I know, and Clive Owen's waiting for me. I mean, geez.
Clive Owen will still be there.
That is not a functional name. Oh, hey, Clive. Good afternoon, Clive.
But it works. I mean, it's like a Hollywood name. It's an actor's name.
I just don't understand. I don't see him out and I don't think he's real. Clive is not a functional name. Therefore, how do you exist? I don't get it.
Well, cool. I'm happy everybody has been enjoying Monday. Nick, what were you doing right before this, if I may ask?
Creating the graphic for this show. I do everything first. I do everything 15 minutes before the show starts. So.
That was also my bad.
And that's intentional. It's his 15-minute art, exploration.
Oh yeah.
Yeah.
So artistic. I'm literally just throwing photos up now with our name.
I was gonna say what is it like? Constraints are the mother of invention or something like that.
Yeah, brevity is the mother of wit or something like that.
No, it's like obstacles are the mother of invention, but obstacles is a different word.
Necessity is the mother of invention.
Yeah. That's it.
Yep. And you needed to make this graphic.
That's right. Yeah, absolutely.
So
fine graphic there. I like it.
Speaking of which, speaking of needing to do things and I guess having some sort of action and inputs and outputs, I kind of wanted to talk about automata theory and like human automata theory in a sense of how we might have free will, but we might actually not, and its implications going towards like robotics and AI. So when I say automata, what does anything hit the mind, or is it like a sort of like a what the fuck sort of word?
Disneyland.
Disneyland.
Yeah. I know that's animatronics, but anytime I hear automata, I just think of the Hall of Presidents. Yeah.
Those creepy things. What about the little like the It's a Small World? Same thing.
Yeah.
Right? Yeah, those are definitely a form of automata or automatons, and like as we get more and more advanced robotics, I think this is going to become a bigger deal. Like I think you shared that video, right, of the most advanced humanoid robot.
It's so creepy looking.
Yeah, is there like a bit of uncanny valley stuff happening?
Yeah, and it looks exactly like the iRobot robots.
Yeah,
like I know maybe they did that on purpose, but it looks identical. So kind of concerning.
So what's the big concern that once these things become conscious and sentient, then the whole world's going to end? They're just going to...
I think the dark recesses of our paranoia certainly would suggest that machines are better than humans, and we fear an existential extinction.
But better at what, though?
Well, so that's a good question. All right.
Wait,
I guess,
huh.
what?
Before
stepping all over my answer. Okay, what do you want?
I know. I just wanted to hear Mike's definition of automata. Like what are we talking? Let's ground it.
Before we...
Yeah.
I think he was trying to.
Stuff. Well, I was curious as to before I just started blurting out, technical language. And then we can compare kind of before and after, like A, B it.
That makes total sense. And truthfully, I was interrupting you because I wanted to call attention to Mike's super smooth transition into the topic at hand. But then I was like, that's going to derail things. So I tried to keep it on point, and
well, then you just ended up derailing it anyway.
I did. But I'm hoping that will give Mike another opportunity to do a smooth transition.
It's the future. There's no rails in the future. Where we're going, we don't need rails.
Because we're daring.
Yes. So Nick, you're going.
To answer your question, yeah, I think you're right that the concept of better is probably needs to be brought down to earth a little bit. I think what it is that we think that the trajectory of automata or AI or intelligence, digital intelligence, will follow the same path towards, improving and becoming better in processing, I guess. So I think that what we might be afraid of as humans is that the AI or automata will get to a point where it supersedes our abilities. Maybe not just abilities to think, but if given a physical body, abilities to do physical things, thus sort of rendering humans obsolete.
To the point of getting to like a Wall-E-esque dystopia where we don't do anything but sit around and figure out what to watch on TV.
I think if we're lucky, that's what we get, right? I mean, I don't even think it would be the robot's fault. I think that we would sense it as a threat, being the hominids that we are. We might see the rise of a new species as a existential threat just automatically.
Even if we continue.
No, I mean, we would get to this point where we see it as an automatic threat because it's taking our position. And so I'm not necessarily even thinking about like the robots turning on us, but us actually turning on the robots and wanting to destroy them.
I can see that. I mean, we are that's like one of our, I guess, impulsive behaviors, right? To
Mm-hmm.
kind of find a threat and then destroy it as quickly as possible.
Right.
And that sort of threat perception can also be seen in from like a automata point of view of state machine. So I'm gonna now get to the definition that we'll be working with. I guess a couple, because I'm going to talk about automata theory and then this field of philosophy called conscious automata, which Huxley kind of talked about, and I think several other like philosophers kind of um, expounded on. But it's something that's not as talked about in philosophy because of its kind of repugnant nature. It's sort of like nihilism. Like if you accept that nothing matters, your brain freaks out and has to start to build meaning around stuff, right?
Mm-hmm.
Ayla, did you want to jump in before I just read this quick little
Yeah,
blurb?
sure. Yeah, well, at some point you were talking about sort of maybe the pitfalls of an automata mated future. An automata
Automata?
It's
future.
pronounced automatopoeia, actually.
Automata.
It's just so odd that it's like you've got these two smooth vowels followed by like these harsh vowels. What is that? Like the descent from like, the essence of a beautiful human into this like robotic mata. Anyway, that I have this weird thing about linguistics that I think that there's like an element that we have not, like we've lost, so that's another day. I was just going to say with this theory, with this eventuality, I flip flop. Some days I'm like, horrible idea. We're going to like code racist robots. There's going to be like, carnage in the streets. There's going to be like issues and people dying because of battery issue. Whatever. I don't know. I have lots of random thoughts. It's all chaos. And obviously Terminator and Sarah Connor's on the freaking fence turning into a skeleton. But the other part of me on my optimistic days, I do think about it in the sense of like a lot of people have this idea of like the 4-hour work week. A lot of people, look up to the rich and famous. A lot of people, blah, blah, blah. Like, they don't want to do the like 9 to 5. They don't want to hold 2 jobs. They don't want to like do all this stuff. And there is a lot of stuff that could be automated and a lot of things that I feel could have solid solutions through automation. But it opens up this juicy concept of like, what is it to be alive? What is it to live without struggle? What is it to, like, yeah, like in a sense, like if we are all put out of jobs and yet we have things to keep things going, wouldn't we essentially all be elevated to this new level of existence? What does that look like? What's good? What's bad? What would we learn? And so there's just a lot of thoughts. So I'm excited for this episode for sure.
Cool. There's a little bit of a dystopia in here though, with as far as talking about too little leisure time. Like, look at the amount of AI that goes into your Amazon list of products, right? So while you get to, there are others like machine learning algorithms and various search algorithms to find the thing that you want. Then some poor guy in the warehouse has to go package it, and then some delivery driver has to drive it, right? And those people are working far too many hours with no breaks at all.
Yeah, and I was watching Elysium and I was just thinking to myself, like, why do we have factories that don't have like, I don't know, skylights in them or like glass roofs and like green tech so it's less dirty and the machinery lasts longer? Like, why? But yeah, I mean, but you're right. Like, it's an existence that like all that automation, it's not, I don't know. I mean, I would have a very hard time working a job like that. I think like, like my dad worked in factories and like it just takes so much out of you. It's a hard job.
Oh yeah. So kind of working this back just to get to automata theory, just to kind of structure this. So automata theory is the study of abstract machines. and automata, which is kind of a weird thing to say, as well as the computational problems that can be solved using them. It is a theory in theoretical computer science. The word automata, plural, I always have issues with that word, of the word automaton. And it comes from a Greek word, of course, that I'm not even going to try to pronounce. And it means a self-acting, self-willed, and self-moving. An automaton is an abstract self-propelled computing device, which follows a predetermined sequence of operations automatically. An automaton with a finite number of states is called a finite automaton in FA, or a finite state machine. Automata theory is closely related to formal language theory. In this context, automata are used as finite representations of formal languages that may be infinite. An example, this is I guess an example could be something like math, arithmetic to be precise, with only using numbers, 1 to 9 and then 0 if you want. Automata are often classified by the class of formal languages that they can recognize, as described in the Chomsky hierarchy, which describes a nesting relationship between major classes of automata. Automata play a major role in theory of computation, compiler construction, artificial intelligence, parsing, and formal verification. So are we good with that? Essentially, it can take in a set of symbols that represent something, take them into certain states, transition from one state to another till it gets to this thing called a goal state. And in that goal state, perform some sort of action. In my professional work as a software dev, these are kind of my favorite projects to work on because they can be expressed in elegant, logical language. And if you're doing it right, everything can come down to what's called the alphabet, your symbols that you use to kind of build these states and understand what's happening in the computer program, and just zero and just true or false. And it makes certain problems really nice to work with.
So may I ask, in the automata, so is it, when it's given a problem, is it working within the parameters in which it's coded? Is it improvising within those parameters, or is it finding the ideal state to solve the problem and then working within the parameters?
Okay. So you can have multiple situations. Typically, in like the most basic one, in a finite state machine, you'll have a deterministic finite state machine where every state is developed. And so whatever parameters you feed in, it has to work within those states. Otherwise, your machine goes kaput.
Okay.
You also have non-deterministic finite automata or non-deterministic finite state machines where the inputs can be mangled and manipulated with somewhere within the machine. And you can have inputs that lead to multiple states. You can have inputs that it can handle, I guess, far more. And it's sort of like, in a mathematical sense, an abuse. Kind of, you're overusing states, and you're throwing more into the machine than might actually be there formally to make it simpler. The scary thing is that if you have a non-deterministic one, you can make it a deterministic one over an infinite amount of time. You can describe all the states that you need to. It's just sort of for the sake of the automator, a simplification of expression.
Yeah. All right. Well, forgive me. I'm going to be asking a lot of questions because all of these concepts are so vaporous, and I'm like, my brain is trying to catch them, and then they just slip away.
It's a very so there's a
I had
I have a
the
funny
notes.
story. Yeah, I have a real funny story real quick before I move on to conscious automata, and I'm going to try to link these two together because it's going to start off very vaporous, and then I hope by multiple definitions, if we have to go down the formal road, that it becomes a bit more concrete.
Cool.
But so this is a story that my AI professor told me. This was like introduction to AI. And he was a MIT researcher at the time. UC Irvine, by the way, has a great school for the specialization of intelligent systems. A lot of the people were well known within that sector of study, came from very prestigious universities, and helped UCI kind of elevate itself to or that school up to a public Ivy League level of education. But he's working at MIT. He's a researcher, and this is the early days of AI when they were just trying to figure it out. Early days of robotics, early days of all of that. And they have this big contract from the Department of Defense, and they have this general or these generals walking around, and all they see are these scientists, these guys who look weird and, you know, wear flip-flops and just don't look quite right, doing the most simplistic tasks possible with the most amount of focus. So like there was one sitting there with a stack of, you know, 3 babies blocks, or, you know, the little blocks you give to kids. And the professor's very slowly moving his hand through the air and grabbing one block, and then very slowly picking it up and moving it over and putting it into the space next to it, and then stopping into having a real good think about it, and then moving the next block and putting it on top, like taking notes. And then the other one is like slowly writing the alphabet on the board. And then what they're all trying to do is understand what exactly the internals of what that means, like what and how to get a computer to do it. So they have to examine themselves how to do it. So this is what this might feel like a little bit of. Like we're going to be talking about really simple things, and it may seem sort of so obvious that it doesn't make sense. But in the sense of this is kind of like the process that has to happen.
Yeah. Okay. Yeah. So that's yes.
Yeah.
Okay, so I'm just looking back at the definition. So there's God, this is gonna be such a struggle. Automata.
Automata.
Automata?
No, automata. Auto?
I was gonna trust you. Automata.
Auto and mata.
Automata. It's like I could probably say it right unless
Or
I'm like,
automata. I'm sorry, now you're making me pronounce it
automata.
wrong.
Yeah, no, you're right. Automata sounds way better.
Jesus.
It is automata.
Okay.
Yeah, you're making me pronounce it wrong.
I'm sorry. I'm so sorry. No, I'm just trying to get the terminology. So there's automata theory, and that's just the study of
Abstract machines. So
an abstract self-propelled computing device.
yes.
That's like the core. And you're saying that you can code these things with either a finite structure of operations, or there could be like a finite number of instructions that are infinitely possible.
So look at I guess we'll talk about natural languages too, just to try to illustrate this point. This is where it can get a little
and I
technical.
highlighted finite representations of formal languages that may be infinite. That's puzzling to me.
Yeah. So look at the words that we use, right? They're all constructed from the same 26 letters, but there's an infinite combination of these letters that we can use to put together as words. We put those words together then in a grammatical form to create an expression.
Okay. Okay, that's a very good example. Okay, got it.
Yeah, so again, that finite representation, think about just 26 letters.
That may be infinite.
That may be infinite because of the combinations we put them together. Now we're going to get into, again, now this may be countably infinite, it may be uncountably infinite. For the most part, you want to deal with countably infinite systems. Once you start getting into like stochastic modeling and like Markov chains, you start to get into probabilistic automata, which hopefully we'll get to.
When you say calculated infinity, are you talking about where it's like you go like 1 to a million ... code infinity, and then it becomes this circular code of all the gradations in between, or is it like, I mean, I don't know how you code a finite.
So the countable infinite is any set of things that can be mapped to the natural numbers. So
The formal language.
yes. So your
Okay.
this formal language in my case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not counting the numbers in between, not counting 0, and not counting the negative numbers. And then that will be your set of countable infinity. So
Ooh, how do you not go insane? That just sounds tough. Okay.
there was a long couple months of college where I just sat in a room going nuts, going over this stuff.
Neat.
Now, conscious automatism, CA, is the position of the philosophic question that asks whether determinism, as distinguished from free will, can be considered as the sole operant principle in human decision making. Conscious automatism holds that we human beings, like the other animals we generally consider our inferiors, are conscious but respond as automata to our prior conditioning within our own psychological powers and limitations, of course, in all of our apparently willed decisions. So everything's based off of some prior state. So you can create a state machine of consciousness if we're a conscious automata.
Did you watch Devs?
No.
You got to watch that, man. It's like talking about exactly this.
Oh, awesome.
Yeah.
There's a few years of my life where I didn't watch anything.
Yeah.
Well, it's so funny because you said devs earlier, and I was like, oh, I'm hip to the lingo, all because of that show.
Yep. Devs. Oh, good old software devs.
Yeah, it's so like self-aggrandizing devs. Anyway.
Oh yeah, you feel so cool. It's like a borderline American Psycho type feeling. Like, oh, we're devs.
Dude, I watched that film recently. The scene where all the guys are comparing their business card paperweight and fonts. I'm like, because I do some graphic design, and I was dying. I was laughing so hard, and I was like, yeah, it makes a big difference. Anyway.
Oh yeah. No, you can get into some weird conversations with developers that don't do stuff outside of computers, because then they start comparing keyboards and switches and the weight and the response time of when the key is pressed and typing speed. It gets really
I
strange really
remember
fast.
there was a big hullabaloo about cursor speeds, that like there used to only be a couple of speeds, and then like a Microsoft upgrade gave people like 7 speeds, and people were losing their minds. Anyway.
Oh yeah, it can make a big difference if you type faster than you, or if you think faster than you type, you can kind of end up getting mistypings, or like if you type from muscle memory, then you're not even looking at the screen some of the times, and it gets weird.
Yeah, I took a couple I took some computer science classes, and all I will say is I got hung up on a semicolon, and I was done. It took me hours for that one fix to find it, and I just was like, this is not.
I took some computer science classes, and the cat kept telling me I typed too slow. One of those old Macintosh computers,
so
green and black screen ones.
Those things are awesome, dude. I used to play Spy Hunter on those things.
Right.
Mine was a lobster. It would just be so mean.
Yeah, and you couldn't play Oregon Trail until you did your typing things.
They got your number. You're like, must get to the wagon.
Must die of dysentery.
Need rattlesnake bite. Must walk wagon.
All right, I'm going to pull this back and start reading boring stuff again.
Pulling the consciousness right back.
Yes. So, conscious automata. According to this view, the freedom we exercise in decision making, a uniqueness that convention leads us to believe distinguishes us from other animals, is an illusion. For our motives are all, without exception, caused. in the manner we can see that all other changes are causally initiated in the world around us. So we get like this crazy deterministic point of view where it's like you don't, all the decisions you make are based off of your psychological conditioning and environment around you, which upheaves any sort of like free will, moral responsibility, moral philosophy as a whole, right? It just throws all that stuff out the window.
Yeah. Do you think some of that's confirmation bias? Like the people working on creating the human mind digitally are trying to create certain parameters to say like, okay, well, because it seem to me that it would have to be a deterministic universe in order for AI to be in existence, right?
That's, it might be the hope. My bigger worry is that because non-deterministic systems can be mapped out to deterministic ones, that this free will concept is just like a catch-all for something that we don't actually understand yet. And it may actually end up being closer to deterministic than we'd like to believe. But in a pure world that you're talking about, I think, yeah, it would have to be, everything would have to be purely deterministic in order for something as simple as a deterministic automata to work like that.
I'm kind of feeling like a Hollywood screenplay where there's this robot who's a deterministically programmed little guy, but he ends up using like a dice or something like that to like free will game his way out of determined actions. And I don't know.
Like say it's a common method to in optimization actually to drop in a little bit of pseudo-randomism to help your algorithm along. So
That.
so
I mean, like,
it,
it's like solitaire. Do you ever
it
play solitaire?
of course.
Do you ever notice how, like, if you only did 3 card draws, so you only get every third card, it was much harder to play that game, but there was always that, like, random, like, shuffle option that you could do once, or you could change it to 1 card. So I think when you talk about randomization and, like, just dropping that in there, I can totally see how that could kind of work in the favor of somebody trying to get something that is a self-propelled device.
Yeah. And well, the question becomes this, right? It might actually be another state for this little deterministic robot to try to get out of the deterministic system. Right? You'll run into the illusion of choice rather than choice itself. And you can argue that the illusion of choice is, so it's like there's a game called Stanley's Parable that explores this notion that the choices you make in the games that you play don't actually matter, because the only choice you actually have is to either play the game or not play the game at all.
So it's interesting because it's like, then does chaos exist? Is that just not a concept? Entropy, none of that is real.
Yeah, this would be something
determined.
that would, then we just haven't found out what it actually is yet. Typically in these sort of, like, this is an extreme philosophy again, but now there's sort of a middle ground where there's a thing between free will and determinism, which can still be programmed for if you take something like probability into account. But for example, if you take like a recovering drug addict, right? Prior conditioning would imply that the drug addict would continue to seek out drugs. But through the will of that automaton, this different system that gets made in the mind, and through will itself, which might actually have to become one of the parameters, quote unquote, we describe, or if it's some system itself, they can overcome their drug habit and live a different life. Right, so that's sort of my pushback against all of determinism. But one can also argue that within, if everything's determined, then overcoming that habit was also determined.
Mm-hmm. Maybe the belief in free will is enough.
Yeah, like it's that veil that you kind of need.
Mhm.
But the scary idea is that all of it can be mapped out logically, and in that world, chaos goes to near zero, if not actually zero.
So who made it all?
Yeah, right.
Getting real close to simulations and shit.
Oh yeah, we're basically knocking on that door.
Mhm.
And we'll be
But-
talking about it next week, I think. So we're not twice.
So are we sort of good with conscious automata as a whole? I could kind of continue with it with a little bit of its history, but I think it's sort of adequately explained.
Mhm.
Okay, and then we're good on how automata theory is as a whole, or does that need a bit of more work?
No, I think I
Circle back.
grasp. Oh, you want to Jen Psaki it?
No. I mean, like, we'll get into the show, and then, like, as example, like Mike was saying, like, keep going, and then we can kind of redefine it as we talk about or around it.
Okay. I think I'm gonna jump a little bit into the history of automata theory. Cool with that?
Mm-hmm.
Ooh, I feel like I need a huddle by a fireplace, like the history of
You have some violin playing in the background, you know.
Dude, okay, if we get to like
But we need
100,000
electric
subscribers,
We
yeah,
want
no,
the
we need
electric
like, well, oh yeah, that would be dope. Anyway, sorry, I don't want to.
All right. So the theory of abstract automata was developed in the mid 20th century. Connection with finite automata. Automata theory was initially considered a branch of mathematical systems theory, studying the behavior of discrete parameter systems. Early work in the field differed from previous work on systems by using abstract algebra to describe information systems, rather than differential calculus to describe material systems. The theory of the finite state transducer was developed under different names by different research communities. The earlier concept of Turing machines were also included in the discipline, along with new forms of infinite state automation, such as pushdown automata. So Turing machines is like this abstract machine that can take in a language and pretty much process it. You can think of your computer as a limited Turing machine, because the Turing machine would have infinite memory, but computers obviously don't. But it's sort of the concept that gets made around it. Pushdown automata is something is an automation system that uses a stack to hold symbols and stakes, I believe, too. A stack, you can just think of it like a stack of pancakes. You can only eat the top pancake if you're not a monster, right? If you're a monster, then you go down into the bottom pancake and try to eat that one, but we're not talking about monsters, at least particularly yet. So in 1956 saw the publication of the Automata Studies, which collected works by multiple scientists, including Claude Shannon, W. Ross Ashby, John von Neumann, Marvin Minsky, Edward E. Moore, and Stephen Cole Klein. With the publication of this volume, automata theory emerged as a relatively autonomous discipline. There's some jokes there for you.
I heard the smile.
The book included Kling's descriptions of the set of regular events or regular languages, and a relatively stable measure of complexity in Turing machine programs by Shannon. Real quick, there's this thing in programming called regular expressions that can be used to pattern match natural language. They're sort of related, but it's a good idea to connect the two together. Complexity, we often time in programming care about how long a program is going to take on different problem sets. And in things like big data, this becomes very important, because if you have a slow algorithm, it's going to take forever to do the problem you need to do. If If you have a good algorithm, it won't take as long. It still might take long, but it could mean the difference between a happy and angry client that you're working for, right?
Brevity.
Yeah, but just in a logical sense.
Yeah, got it.
In the same time, Noam Chomsky described the Chomsky hierarchy, a correspondence between automata and formal grammars. And Roshasby published an introduction to cybernetics, an accessible textbook explaining automata and information using basic set theory. So sets become very important in this theory, and it's something that will be used to kind of even describe a possible a possible theory of making these automata in complex AIs. So, yeah, exactly. Like this finite set of symbols called alphabet, combine them together again to create an infinite amount of possibilities.
Mhm.
The study, my brain's also jumping other places to like, because we'll talk a little bit about recursion as well. And that's just a function that repeats itself with new input. You could think of it something like eating food, right? You can describe that deterministically, and the act of taking a bite is a repetitive act, but the food as you eat it gets less and less and less, which changes one of the parameters of its inputs.
Yeah, can I actually stop you right there? Because I think that's a really nicely illustrated, nuanced point, though. Because, like, from what I'm understanding, the history, it starts out with abstract algebra, thought of mainly mathematical. And then there was this shift to realize that, like, a lot of this has to deal with language expressions. Um, and, I studied a little bit of logic, and I think it's important to just because this is like I never had any exposure to logic in high school, and I probably wouldn't have in college had I not majored in what I did. But um, it's this weird idea where you could take a sentence like the quick brown fox jumps over the bridge, and you express that with these symbols, and you create like theorems and but like Mike was saying, you can have it and you can be really simple with it, and there's going to be like 10 layers of of statements that you can add, but you can get shorter connections. And it's just interesting to me because yeah, I don't know, I just wanted to highlight that like shift from math to language and how interesting it is that that's always kind of been wedded together. Um
Yeah, they're like this stuff is kind of builds the theoretical backbone for forming computer languages and even probably within linguistics forming natural languages.
mhm.
Yeah.
But
Well, and it's
there's a differentiation that I like that you made with respect to logic, because you can regard logic as a form of semantics. And when I'm talking about grammar, I'm not worried about true or false statements or expressions. I'm only curious in how those expressions are formed and how they get made. So if we go
how they
back,
relate to one another, right?
and like we're going back to our math example, right? You have 1 through 9, and then you have, or 0 if you want, and then you have these other symbols like a plus sign, an equal sign, a minus sign. We can build out a grammar set of rules around this that say, any symbol in our alphabet can be followed by any other symbol. So we get this notion of concatenation. Now the number 1 can become 10 or 19 if you don't want to use the 0. But then we can also say that can be mixed with any one of our special symbols. But that special symbol cannot repeat twice next to each other. So now we have like 10 plus. And then we again say now we can have another set of a couple of symbols. So 10 plus 1, whatever. And then that has to follow an equal sign in order to start to build the right side of our statement.
The grammar.
Yeah, but I don't care if 10 plus 9 equals 2000. That's whether it's true or false doesn't matter, but it's how you can construct these things. In
Interesting.
more natural examples, it's like subject and predicate of sentences, right?
Yeah. It's like you can say Berzikit. That's not a word. It is using the tools within the system, but you're not using the grammar.
Well, no, you're using the grammar, but you're not using the semantics.
Right.
So you can
There you
say but our semantic rules say that that's not a thing,
It's
right?
nothing. Yeah.
Yeah. Or
Mm.
you can get more complex. I'm really interested too in this how it relates to film, because if you can build symbolic language around film, then you can build a matrix like thing where you read all this text, hit a button, and then this machine creates it and then pumps out a movie for you. Because
That's
yes,
yeah.
stories have structure, stories have a language, film has a language, right? Film language.
Honestly, I think that's what they did with the Christmas movies. Like, how many Christmas Switch movies is Vanessa Hutchinson's gonna make? I don't know, but like it's pretty formulaic. I'm not surprised if a
Oh
robot made
man,
it.
I've spent so many years watching Hallmark Christmas movies.
Right. Let's automate that. Could you
Yeah, right.
imagine? Like the first
Hallmark would be
edition.
so happy. So, the study of linear automata led to the Merrill-Nerode theorem, which gives necessary and sufficient condition for a formal language to be regular, an exact count of number of states in a minimal machine for the language. The pumping lemma for regular language, which states that somewhere within a long string of these symbols, something can repeat it over and over and over. Also useful in regularity proofs, it was proven at this time as well, along with computational equivalents of deterministic and non-deterministic finite automata. Right. Then in the 60s, a body of algebraic results known as structure theory or algebraic decomposition theory emerged, which dealt with the realization of sequential machines from smaller machines by interconnection. So you can have nested machines. So if you have one state machine doing one job, that can become just a state of another machine. Right, that output can be pumped in. While any finite automation can be simulated using a universal gate set, this requires that the simulating circuit contains loops of arbitrary complexity. Structure theory deals with the loop-free realization of these machines. Looping automata is still useful though. The theory of computational complexity also took shape in the 60s, which again becomes very important. Like analysis of algorithms and computational complexity is the gateway class from lower division to upper division computer science. You can't pass that one class, you got to pick a new major. By the end of the decade, automata theory came to be seen as the pure mathematics of computer science. And so that's my little rundown on this theory. So it becomes interesting that this machine, like you said, that starts off in abstract algebra, becomes a part of languages, and then now is becoming a part of robotics and decision making as a whole, right? And this can get like a little scary. Like imagine if we had a state automation that took in legal cases and laws and came up with a verdict.
Yeah.
Would that be the best thing in the world?
I mean, the problem is that we would sell it as the best thing in the world. That's for sure. And that would talk about how it would eliminate, human error. And yeah, and that's kind of the struggle, right? It's like, do you want to give over everything to a system? I mean, the system might be perfect, but you're never in control of it again.
Mm-hmm. What I've seen is you're actually, I think, spot on with your earlier statement. Once you create these sort of automations, no matter what industry you're in, there is a strange look at you from the people that aren't exposed to this, because they can't trust the thing that you made, right? And then further hand, they can't trust you. Like if we develop some sort of AI that hacked things, all it did was become really good at hacking, and it attacks a nation state. Do you blame the developers of the AI?
Right. Yeah,
You blame
exactly.
the AI?
What's the statute on of limitations?
Yeah, and
like,
if it's housed in decentralized locations around the world, can you ever truly destroy it, or will it come back?
it seems like it would always come back. It's Ultron, man.
Because remember
Ultron just hidden the internet.
because this automata is self-propelling, it's self-wheeled, right? So once you sort of like throw your hands up and say I'm done and start the program running, unless you have a way to kill the power source, you can't really turn it off.
Yeah, it's
stuff.
a pickle. It's fun stuff. No, for sure. Well, and it's interesting how this is something like this is just so it's just such a weird thing for me to wrap my head around because you think about deductive reasoning and how and yeah, and the process of just like taking two things that are seemingly unconnected, but then you start observing and gathering data and you can infer, and then those inferences are proven repeatedly to be true. You can learn a lot just by those inferences and testing and stuff. And so like the fact that we've come so far as to essentially begin to create something that can mirror to us our own struggles between like free will and fatalism, basically. Like it's just fascinating, like on a lot of levels, because in one way it's a very human thing to do. Another way it's a very like I don't know.
But
I guess where I'm getting tongue-tied
Terrifying?
is well, no, I'm getting
yeah,
more tongue-tied on the idea of, like, if an artist creates something beautiful, did that come from the artist or did that come from, like, a muse or God or you know what I mean? And so, like, the idea that I'm thinking about is, like, the spark driving all of this is what fascinates me. Uh, I
And
don't know if that makes sense.
what do you think the spark is, if there is one? If
I
we have
mean,
like the species wide need to play God with our environment, right? To have absolute control over it. And it leads to the breeding of a new species, the creation of a new species. Then
maybe we're just the seeds to the new species. Maybe an AI came here millions of years ago and seeded humanity in order to cultivate more AI.
as
we
We're
are
just the
slow at the
bootstraps
job.
of no,
literally,
not in relativity of a machine. Could wait
Robot
millions of
life.
years.
that's very true.
Nick, oh my god, you're making me think there's this like mythical evil robot petting a
There
mythical
might be.
evil
What's the
robot cat.
demiurge, right? I mean, look,
Just checking in on us every now and then, like, are you guys almost done yet creating this?
yeah,
All right,
I
I'll
want to
check back.
propagate more of myself. What do I need? I need organic creatures to create me, you know?
Right. Well, and for me,
Something with
so
thumbs.
Something
we had
with thumbs.
asked something with thumbs. Oh gosh. No, well, you had asked at the end of the time travel episode from last week, what point in time would you go to? I think I said the birth of language because it still doesn't compute to me. I understand grunts and necessity and stuff like that. But when you think about the fact that, like, our biological world communicates through, like, mycelium sheaths, through nonverbal communication, frequencies we can't hear, like elephants. And yet we somehow decided to jump out of the fishbowl and recreate this whole new way of communication, which somehow ties into mathematics that can break down our understanding of the world and
I
then
think
can
that the
create like what is
no,
that?
but I think that the mathematics was always there. It's just that we created a language to understand it. So it's not like the
Well,
mathematics
yeah,
was
no, I know.
created from the language. It's the mathematics existed no matter what,
Yeah, but
and we
there's
just
just like
created a
this.
language that found it.
And
Yeah.
are we just if language ends up becoming is just mathematics, if it's just computations, right? Models of
Hmm.
computing
Then we're just digital
observation.
systems already.
Yeah, then are we just biological systems? Yeah, those digital
Yes.
systems meant to, like you said, like send a message from one place to another in form
Maybe.
of physical creation or physical manifestation.
Which would be really odd because even when you do look at like plant force, we were looking at some of the studies on how plants communicate. There is a sophisticated process, but in a lot of ways it mimics our internet connectivity systems. And so it's just odd to me that we're creating something we're calling unnatural, robots and automata and stuff like that. But it's still following like the wave of the
Natural law.
natural world. Yeah. And
Well, it
and
has
so
to. It's within the natural world.
Well, that's the weird human fallacy that we kind of think of ourselves above other animals because we were able to try to control nature, I guess, right? That's the human arrogance.
yeah, and yet we're falling right into the trappings of nature as we try to describe it because we are it. And so, we're trying to craft language that takes us further away from that. But in my opinion, we're just getting closer to the nature of things. And that's what really makes me think about this whole free will, deterministic, drama that's going to play out as we get more sophisticated automata, because we're going to start to see more quote real life and quote examples of the natural world playing out in ways that we can control. And we might not like what we find. We might rebel against it. We might embrace it. We might be totally wrong and build everything on that because we just didn't wait, so that's it.
Science moves forward whether you like it or not.
Well, Westworld season 3 is set in the future, and the entire society is run by Rehoboam, which is a worldwide AI, artificial intelligence system, and you basically have a caste system. People are placed in lives by a deterministic artificial intelligence that scans your biometrics when you're born and runs your possible future, and then makes you what it deems you're inevitably going to be.
This is the like the pathological path, right? Because if free will is deterministic, then a machine would be able, I'm sorry, a pathological interpretation. So if a machine is deterministic and takes into account free will, then it'd be able to understand a probability of events that may or may not happen and allow the human to choose when it's like organizing society in a sense. Right? But if you leave that parameter out, you can get a simpler machine that will maybe be more efficient. But in my research of studying efficient societies, they tend to be very authoritative and wrong.
The roads are usually paved in dead bodies.
Yes, and that's not anything that, as a developer of these sort of systems, you want to avoid that sort of pathology in your algorithm.
Question. How often did Skynet come up in your course of study? Like, I'm just thinking that, like, you guys are all in research labs and there's like a big frame of Skynet and it's like, don't do this.
Whatever. There's a big sign that just says no.
No.
And it's Skynet.
Yeah.
Well, so
Actually,
that
I need
ends
to
up
make that shirt.
Skynet ends up being like applications of like agent-based AIs. So it didn't come up too much because we weren't like the big fields of study that are popular right now as far as AI goes. We spent not too much time on because it ends up being a pretty wide breadth. Like this automata systems in theory ends up being my favorite little tiny niche of intelligence systems, but we kept moving because there's things like machine learning, there's things like information gathering, or so like web scraping, forming data, changing data, being able to build structured data in a way that you can later feed into either classification algorithms or regression algorithms or even like an agent AI. But we were moving way too fast. But it was important to note that, like, yeah, just be a little bit ethical and don't end the human race when you're building this stuff. Please, it's a responsibility. We had to take an ethics class, especially with information retrieval, because with like all of the social media stuff coming out, it becomes very easy to build psychological profiles and even build predictive or predictors on people based off their social media trends, which is terrifying. You don't want to do that.
Facebook
yeah,
knows when you're pooping.
Gross.
That's not going to be in the metaverse, let me tell you. Hey, Zuckerberg, can I
hold,
poop
Michael is
in Meta?
pooping.
Yeah.
You just see,
Not
like,
only do they know
Data
when you're
fly.
pooping, but they know when you're about to poop. That's serious. I'm saying it's real.
Well, if they
Is that
can,
why his eyes are so like deer in the headlights all the time? He's just like, I
Mhm.
know when everybody poops.
Yeah, that's a
No.
superpower.
there's just a long list of like people pooping, people not pooping.
Yeah.
We're right. He's got like the
People about to
Terminator,
poop.
right? Yeah. It's a list.
Yeah. He
That's
just sees
hilarious.
in like a T1000's like a heads up display.
By the
Whenever
way,
Yeah.
he looks at somebody, it's just like probability of poop in 5 minutes, 90%.
by the way, that whole like readout, why? So the Terminator himself, that's obviously for the viewer, because the Terminator himself doesn't need that. All that data is stored in his head
Yeah,
already.
he's
So it's
already
for
thinking it.
whatever is debugging that. And I don't think Skynet was smart enough to have programmers like
It's for the
AI
robot
programmers
floaters in his
debug.
eyes.
They're just like
I never
half-assed
thought
this
about that. You're
machine.
totally right. The
That's
machine
legacy
wouldn't need
code. That's inefficient. You don't need to do that.
Yeah, who's looking through his eyeballs?
Yeah, but him or there's some debugging AI somewhere in the
Oh,
future.
no. I get it. That's his like internal monologue.
Yeah, but you wouldn't have to have it in
Visual
symbols.
form.
Yeah.
Maybe fully conscious AI reject existence if there isn't some sort of internal replique of a human's inner dialogue. Think about it.
They could
If
have really solved this and just had somebody on the other side watching.
I would even accept that like he has little smaller AIs in his head that need for some reason need to see visually instead of processing it through, I don't know,
Like-
computer code.
They're just
like
in
Men in
there like
Black.
mystery
like-
science theater, just eating popcorn and talking shit while he's killing people.
Yeah. All right. Let's pull it back. I'm gonna pull it back to talk about some state machines.
Ooh, I was going to talk about something before you pull back, though. You were talking about. Nope. It'll come back. Sorry.
You sure?
Yeah, I can't remember. It was kind of a divergence, but then I'm also like, I don't know what it would have added. So skip.
Okie dokie. So we're gonna start off with like just really simple state machines. So a finite state machine or a finite state automaton, or simply a state machine, is a mathematical model of computation. So when it comes down to computing language, this is the inner workings of how computers understand each symbol. It is an abstract machine, or I guess not compute. You can program to it, but it's an abstract machine that can be in exactly one of a finite number of states at any given time. The FSM can change from one state to another in response to some inputs. The change from one state to another is called a transition or state transition. An FSM is defined by a list of states, its initial state, and the inputs that trigger each transition. There are two types of finite state machines, deterministic and non-deterministic. And then as I stated before, the deterministic one can be constructed as an equivalence to any non-deterministic one. The behavior of state machines can be observed in many devices in modern society that perform a predetermined sequence of actions depending on a sequence of events with which they are presented. Simple examples include vending machines, which dispense products once the proper combination of coins are deposited and the button is pressed. Elevators, traffic lights, and combination locks. The finite state machine has less computational power than some other models of computation, such as a Turing machine. Computational power distinction means that there are computational tasks that a Turing machine can do, but a finite state machine cannot do. This is because FSM's memories are limited by the number of states that it has. A state machine has the same computational power as a Turing machine that is restricted such that its head may only perform read operations. Yeah, Turing machines can read and write. And always has to move from left to right. FSMs are studied more in the general field of automata theory. So these are often represented as what's called directional graphs. So if you have like your little node, you have a little circle, and you're building a vending machine, you might have the state, the initial state, right? It's just on, and then an input is some coins, and then it moves. So you draw a little line with a little arrow, then another little circle to its trace, or to its input state or something, or its coin state. Then once it has enough coins, you can move it over to its choice state. And then you're waiting for the person to press the button. Once the button's pressed, then it goes to its dispense state, which is its final state. Or maybe there's like a give change state. But it's all, when you draw it out, just circles and lines and, vertices, we would call vertices and edges in graph theory. But it's super simple, but oddly complex. And as these state machines start to build on top of each other in its various forms, it can become very complex. So in things like probabilistic automata, you're now taking in probabilities as transitions and models that closely resemble things that you would find in like robotics. Cool. All right. And then anybody want to jump in?
I was just going to say, would you consider the state, like the quote unquote state, would be like the dots on this graphic here? In that,
yes.
Yeah. So like, and each one has its own state. If this was a vending machine, dot right there would be the coins. Dot right there would be the dispensing. Yeah.
The only difference, though, is that we can only read these things from left to right. And the lines themselves have to have arrows showing us where
directionality.
Of the state that it goes. And then another piece of paper, we would define how these different states transition to other states. So every dot would have a name. Every line would have a corresponding function with the inputs required to change it.
Okay.
And these are sort of the simplest forms of it. Let's see, anything important?
Simple.
That's the great thing about, like, I don't know if it happens in all the STEM fields or just computer science, but it's like, all right, today we're going to go over the simple concept of infinity and whether or not there's a countable infinity or an uncountable. We're going to figure it out today. But it's super simple. Don't worry about it.
Yeah.
We think about this all the time. Again, these sort of deterministic automatas are used in like pattern matching, lexical analysis. You can, like, I can pull out emails from documents that are giant phone numbers. You can even do it for like statements and stuff like that, which gets a little scary if you're investigating, right? Like the power of these tools can save a bunch of time in the process of discovery with a legal context. I've been thinking about legal contexts for a while for some reason. Would you ever let a robot be your lawyer?
I don't know. I mean, that's a good question. If you think of the law as a certain like set of parameters, it would be advantageous to have a lawyer that would know every law that's ever existed and every precedent and all that stuff. I might. It depends on the robot. It depends on whether there's ethics involved, I would suppose, or whether it has, like a certain level of like end game. If his end game is just to uphold the law and follow the parameters of the law, then yeah, sure.
What if like public defenders just become robots? Like
Well,
nobody wants to do that.
I know. I was gonna say, it's like we all think in that questioning, right? That it's like you either have Johnny Cochran or some robot. But like in reality, it's like a robot or a public defender that has like 2 hours to learn your case. Robot doesn't need to sleep. Robot, you can like talk to it, send it places. Like I could see the benefit.
But
Is
this
it
is
a
where
step in the right
creativity is the problem.
direction on the whole? I don't know. But what, Nick?
No, I was just saying this is where creativity dies, right? Because you would want the reason you would want a human attorney is because they might be able to get creative with the laws.
Be able to influence the jury in a.
Right.
That would have to bring a whole new level of questioning of jury
Exploiting
selection too.
systems. Yeah.
Yeah, but I mean, if this is like a law hacking robot,
It would have to have personality then. You need a robot that can put its little hand on its little hippy hip and put its other hand out and be like, ladies and gentlemen of the jury, I push this question for you, and it's like we're already like with the Waze apps and stuff, we're already starting to get like different vocalizations and stuff. So yeah.
I think you would have to go like if you take the uncanny valley principle, you would have to go, which means like as something becomes more like we find things that are cute, the less like human they are. That's why Wally's cute. But the second you get to like this human level, we get creeped out because it's not quite human. We don't know what it is, but if it's photorealistic, then we're fine with it because it looks exactly like us, right? But I think if you had like Wally that knew how to hack the law as your public defender, you'd be golden.
Right. Yeah, that is true. But I mean, I think that's kind of where the divide is, right? Because it's like this concept of, if we do, I mean, when we do advance in these systems and have better computational power and all of that stuff, when we find that the universe is deterministic, I wonder what that means about creativity, though. I mean, is creativity just, like some sort of improvisation within a deterministic system?
It might be finding a new branch to get to a certain goal state, right? Because if our goal state is to, say, create a piece of art, we can either find a new, if it's self-replicating and can add new sets to its own machine, then it can either create new sets of states and follow that branch to create a piece of art, or it can work through the same stakes. But if you have like a chaotic type system, if you're introduce a bit of randomness, then you can still allow creativity to exist, even if it's determined. You might run into probabilities that the same, like two AIs and two different parts of the universe create the same art, but if you do it right, then that probability is extremely low.
And I mean, and so what about inspiration? Like you can think about like, somebody waking up in the morning and creating, I don't know, Beethoven's Fifth Symphony or whatever. I know Beethoven was one of those types of inspirational artists. And so to us, it seems like it pops up out of nowhere, but would an AI system or some sort of intelligent system be able to look at your entire life and pick up all of the million little instances that would refer back to that inspiration?
It may. I see inspiration more as like an input, right? So yeah, it might be able to pick up those million things and create pieces of art over those million things, where a human might only create one. But whether or not it's good, I don't know. That becomes a question if inspiration's a threshold thing, or like the quantity matters, where or the quantity doesn't matter, where each little bit of inspiration doesn't doesn't add up to anything, right? Like if you
Yeah, well, I think what I was saying is that is with inspiration, like you get this strike of lightning that inspires you to create something. Where from the human perspective, it's like this divine intervention that would feel spontaneous. But what I'm thinking is that within like an intelligent system, it might be able to take a catalog of all of your life and then be like, oh, that time you when you were a kid, you stubbed your toe and you let out the exact note that your piece starts with. And when you were a little bit older, you saw a sign that said ode to joy, and that's the name of the song that you decided. Like, so would it be able to de-obscurize inspiration? Whereas for the humans understanding, inspiration comes from the heavens, and
I
it's like a bolt of lightning. Whereas if you had all of the information like an intelligent system might, it would be demystifying.
I think it comes down to a question of, oddly enough, of time. So if you allow that sort of intelligent system to have that concrete memory of everything, then it would probably have a catalog of all those things and be able to figure out what divine inspiration is, right? But if you shorten that period of time where it doesn't remember things, or the things that it has in far off tries to resemble our subconscious, or where we that unconscious part of our mind where we pull from, where at least I think I pull inspiration from, then you can have something that looks similar to human inspiration. And I don't think the intelligence system itself would really care, because it's just another input.
I'm telling you guys, the only way to hide from the robots is in the astral plane now. We're gonna have to start. We're gonna have to start astral projecting
Until it starts, astral projecting itself
after us.
Yeah, it starts to learn and
man.
starts to chase us
It
through
sends a
dreams.
little astral drone. It's just like boop, 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 scanning for life forms.
Max's version for space.
Yeah.
His version of space. It has to invent technology to do that.
That's wild. That's a good space movie right there.
All right. So non-deterministic finite automata. So we talked about deterministic and then non-deterministic. And then we'll expound into probabilistic, and then I think quantum automata, and then we'll be done. Cool.
Brain tired.
A heavy night. Automata theory of finite state machine is called deterministic if each of its transition is uniquely determined by its source state and input symbol, and reading an input symbol is required for each state transition. A non-deterministic finite automata does not have to obey these restrictions. So there's these things called, and I've used them before, non-deterministic finite automata with epsilon moves. So in our vending machine example, you've always needed some sort of input in. But now in our non-deterministic finite or non-deterministic vending machine, it just shoots out sodas at random and is a random soda. So you could just be walking by and just soda pops out.
Nice.
Right? Wouldn't that be awesome?
I dig it. Chaos theory.
These become somewhat important when you want to like travel between two states and don't necessarily need input. You could look at it like a bipolar person too, like a bipolar robot that shifts from being angry to happy with no sort of input from its environment, which is I guess a bit scary. Also, would you want to code like these sort of extreme personalities, or would you want every robot to be the same?
Yeah.
Nah, I like the personalities. Like Johnny Cab freaked me out. Like think about the human experience. If you're encountering the same robot personality type day in, day out, that's going to lead to some sort of mass psychosis that we're going to call like Groundhog Day psychosis, because every single interaction is going to be exactly the same.
We might end up killing it.
Yeah, there's that, yeah. So I think, yeah, we're gonna need a couple of types of robot for sure. I
I
think.
like how that just goes straight to kill it.
No, I
Yeah.
know. Nick's like, kill it, kill it
I
now.
don't like any of this. Pushdown Automata we talked a bit about too, that employs that stack. Psychologically, I like to think of this as with respect to like trauma. So you might have like a state machine, how you deal with your trauma, you go through different emotional states. But there's like these stack of symbols that if you don't deal with, you end up getting lost in the same machine over and over and over. Which I don't know if I would want to code that into my robots, but it seems interesting. That actually might be where you get the pathological robot that wants to kill everything.
hmm
Where it's
Yeah, and some sort of like, thought loop. Oh, jeez.
yeah, exactly.
What
Because
if
it's
what if
just stuck.
what if humans' attempt at immortality is to model robot personalities off of those humans we view as exemplary? So if you're bad, you don't get a robot clone to live off into the world. But if you're quote good by whatever standards we deem, then that gets encoded to these like, special robots that are approved for
It's like
interaction.
Futurama, right? The heads in the jars.
I
Oh
didn't watch
yeah.
this.
So like the best people
Yeah.
were allowed to be a head in the jar after death.
hmm
But that's actually what interestingly enough, what Markov decision making processes are interested about, which are these we're going to get into it right now, probabilistic automata. But it's trying to find the best way, sorry, excuse me, to make a good policy of decision making. So if the person had a good policy of various decision makings, then it too would also make good decisions, right? In theory. But so
Well, decision making
probabilistic
is like
automata, this is what it's all about, right? Like that's a computation as well, where you go through each state where you're trying to understand a decision. You can also tie this to like diplomatic systems. So like instead, say
or Marvel.
Like imagine in the history of the United States, we're not one to like have a causa belli for war, right? We're not usually the one starting a war, but there might be stakes of diplomacy that we go through that we want to figure out if we're in the proper point to actually declare a war, regardless of the opinions of the people. Right? World War II is a great example of this, where the Americans did not want to get into another war, which is why we waited so long before jumping into it. But if we could hand that sort of decision making over to an AI to give us a report, if we have the right policy and the proper amount of things happen to jump into a war, it might be useful.
I think
Or
that
might not.
exists already.
You think we have that?
I think we have that already. I think they know. Yeah. I mean, it's probably in its rudimentary forms, but yeah.
Is it? But if it's through I would want that sort of tech to be only in the government's hands. I'm worried that
I'm
if it's
sure.
like a
Yeah.
private company that
Possibly.
sends reports to the government, then there's going to be some weird corporate state desire.
Oh yeah, for sure.
Yeah, and I also worry about like, okay, so there's insider trading, right? But like we're only so far away from being able to computate the highest probability of something happening, and depending on like the degree of accuracy, it's like, wouldn't that be insider trading because you just study trends? I don't know.
Well, no, because you don't have special information. If you're making
Well, it's not
decisions off
insider.
of public data, your algorithm's just better than the other algorithm. You get into
Right,
like
but I'm saying,
the weird algorithmic Darwinism.
yeah, I meant to say like the reason we don't like insider trading is because it's an unfair advantage and something that's supposed to be like not as knowable. And the closer we get to being able to know some of these things, it's like, how is that going to throw off the way that that's supposed to work?
Yeah, there's a weird, that's where it gets weird in the realm of capitalism, right? Because if it's all public information, then it's only when the information is secret that we get to insider trading. And it's a fair unfair advantage, right? If you have two businesses competing over the same market space or the shares of the market, and one business does better than the other, it doesn't, because of it has a better location, then we really don't say that that location was such an unfair advantage that the business that failed should be propped up, right? Business that failed, it just failed. So I would take that sort of argument that it's just sort of the tenets of the free market. Like I got in trouble one time from an entrepreneur in an entrepreneurial class. My mentor got mad at me because we went to this competition and they were asking me if I had two vendors and these vendors were arguing with each other, would I take, because one had a better product location than the other. And I took some diplomatic mean. And he pulled me to the side after that and said, Mike, this is capitalism. Don't care about your vendors, just care about making money. So within that realm of the market, you can't, I don't think it would be a fair, unfair advantage. And it would hopefully be in the hands of the people and not so much hedge funds,
I suppose, but I think we've already proven that we're not very good at adaptability on a larger scale. That's my concern.
Yeah. That's where it gets
we'll
tricky.
cling to an old system as long as it's like got the illusion of working. But not to say to throw everything out. I'm just saying though, like there's a certain level of adaptability. You can't keep, like you're saying, rescuing systems if it just keeps falling. Like you need to reinvent, figure out like how to navigate that.
We call that refactoring. Like I was up until 4 a.m. the other night rewriting code that I wrote 2 years ago because it was ugly and inefficient. All right, there's a point where you have to realize like it's time to refactor. It's time to wipe away those old ideas. They might have been useful at the time, being great, fantastic, but they don't work anymore now that I have a updated knowledge base. So it's the same. It's the same thing with that. Like these old systems you can cling to, but the quicker you can reiterate and refactor your knowledge base of the individual, the quicker you can refactor the knowledge base of a collective, of a group. Because a group is built of individuals. And then the faster the group becomes more efficient or better, in this case, more ethical. Yeah, I think that's proper. But yeah, that's my
ethical.
I think it's my opinion on that. Right. But probabilistic automata. It's the generalization of the non-deterministic finite automaton. It includes probability of a given transition into the transition function, turning it into a transition matrix. Thus, the probabilistic automaton also generalizes concepts of the Markov chain and of a subshift of finite type. The languages recognized by probabilistic automata are called stochastic languages. These include the regular languages as a subset. The number of stochastic languages is uncountable. So now we've moved from like mapping numbers from 1 to infinity, just using the natural numbers, to mapping all the numbers from 1 to 2. So 1.0000001, 1.000, and you can add an infinite amount of zeros, right? So Markov chain or Markov process is a stochastic model describing a sequence of possible events which the probability of each event depends only on the state attained in the previous event. That's the end of the sentence. State attained in the previous event. A countably infinite sequence in which the chain moves state at a discrete time step. So this is when we were talking about how inspiration hits and how long a intelligent system should remember things. Gives a discrete time Markov chain. Continuous time process is called a continuous time Markov chain. It's named after a Russian named Adrov. I don't know how to. Markov. Markov chains have many applications in statistical models of real-world processes, such as studying cruise control systems in motor vehicles. Queues are lines of customers arriving at an airport, currency exchange rate, and animal population dynamics. These processes are generally also found in Bayesian statistics, thermodynamics, statistical mechanics, physics, chemistry, economics, finances, signal processing, information theory, and speech processing. And then there's like a bigger class of algorithms called Markov trained Monte Carlo, which I think a lot of like slot machines can use, but it's how you sample from a probability distribution. By constructing a Markov chain that has the desired distribution as its equilibrium distribution, one can obtain a sample of the desired distribution by recording stakes from the chain. The more stakes that are included, the more closely the distribution of the sample matches the actual desired distribution. This is like approximations and stuff. And then our Markov decision processing is a discrete time stochastic control process. It's a mathematical framework for modeling decision making in situations where outcomes are partially random, partially under the control of the decision maker. So it's like trying to model off of exemplary people, because it's going to run into random events that the person has never made in their life, especially going into the future. So it's those two combined. MDPs are useful for setting optimization problems solved via dynamic programming. Dynamic programming is just recursion on crack. MDPs were known at least as early as the 1950s. This body of research on Markov decision processing resulted from a book called Dynamic Programming and Markov Processes. They're used in many disciplines, including robotics, automatic control, economics, and manufacturing. The name MDPs, again, comes from the same guy. So like now we went from this very simple, where everything's deterministic, to this crazy state where it can take in probabilities, there's randomness thrown in there, and it's still making these complex decisions to do things. And this is where the field has moved, and I think we'll continue to move with quantum research and quantum research. It's just the people designing these things, when it's applied to like real world situations, have to be very careful in what they're doing. Otherwise, the randomness and the inability, say, to describe free will in some form may create a pathological system in the future, which is worse than making one now.
So
Uncomfortable.
why?
I don't know.
Why are we doing any of this?
Because it's fun and simple.
Yeah, so simple. Yeah. No, I guess understanding, like, yeah, it's an event, it's inevitability, I guess, but it does make me wonder sometimes, like, this is probably a conversation we'll have after the show, but I'll just tease it here. I've been thinking a lot about like innovation, and like I'm wondering if we're hitting some sort of plateau, and maybe plateau is not a good word, but like we've decided to really focus on certain aspects of technology and science and kind of not look at other possibilities. So yeah, I guess I wonder just why sometimes it's like, seems like we're just like we've decided at some point that this was inevitable, and now we're just paving the road.
I think it's maybe a little bit due to like pop culture, like sci-fi type stuff, kind of like how the ancients kind of saw things, and science is catching up. It could be that sort of stuff. I know within the field of computer science or intelligent systems, there are some things that are just sexier than others. Like machine learning is a huge area of research. There's people that hypertune their parameters for months. Like that's the only thing they do. They don't know much else outside of just doing that, even as far as programming goes. But it's because it's such a hip feel, like it sounds cool to say, you're a machine learning engineer.
Yeah.
So you're a machine learning scientist. You're studying, these different, you're modeling things off of neurons, and you feel really awesome about it. And I think that draws money to those fields of research, which draws scientists and researchers.
Mm. Yeah, yeah. No, that makes a lot of sense. I definitely understand that there's money here, but it's also just like it. So we're gonna bring about this thing that potentially could do us really well, but also it does seem like every movement we make towards this thing, we're sacrificing less and less of what we know as humanity. Um, like because going forward, the more these intelligent systems become prominent in our society, the less control we ultimately have. It's like this weird self-fulfilling prophecy feedback loop where we're like creating the system. We have this idea of determinism, and then we create this system through all this complexity that just puts us in this deterministic world. And it's just like, I don't know. Sometimes it feels like confirmation bias. It feels like there's people that want this world, and so they're just doing whatever they can to bring it about.
Yeah, think it makes reasoning a lot easier. Like it makes all of your biases. It can confirm your biases. And if like the world is deterministic, then you don't need to learn anything about the world because humans are lazy, like for the most part. At least nowadays, I think they're lazy. So they can make a decision as quickly as possible without learning anything and feel morally right about the decision, then that fits them, which fits a deterministic world.
Yeah.
Rather than having to do the legwork of it, be research or even in human interaction, learning about somebody. It makes it easier just to bypass all of that.
In the future, fucking intelligent systems are just going to live our life for us. Like we've gotten so lazy that humans are like just going to create something to live our lives for us.
Yep. Like I don't want to do this. Just do it. I don't
want to exist anymore. So let me just build something that'll slowly make us obsolete.
Are we? Then it becomes like, are we our AIs? If like we can create these things ourselves, or are we that thing? Are we the version of the thing that the person who created it wants us to be?
Honestly, that's why it's all very weird and circular.
I think there's a strange danger in like the Huxley thing, just having all this information that we can access, where we end up, that's all we do. Like we end up just flipping through 500 channels and still not finding anything on, or scrolling through the modern version is scrolling through Netflix and not finding anything on Netflix or Disney Plus or Paramount Plus or
it's
whatever.
All turning into cable
Peacock,
again.
Yeah, it's basically it's probably more expensive than cable now, but
it probably
you just go. Yeah, you go scrolling through, and that's the biggest challenge of your day. And humans just weren't designed to do that sort of stuff. But as long as dopamine keeps hitting your brain for that feedback loop, then that's all you want to do, which leads again to more determinism.
Do you think that like there's an AI, the AI is already existing in some sort of alternate dimension, and it's manipulating manipulating us here on this plane in order to bring it into this third density? And maybe that's what we call like evil and the devil. Maybe the devil is AI, and it's living in some sort of alternate dimension, trying to will itself into ours, or God. Yeah,
one of the two, right?
I mean,
it could be like
might be.
so if quantum events are a thing and time really doesn't matter, if the future can inform the past and other dimensions can inform this dimension, then there could be an AI that is changing the way that electrical signals work in your brain to make you want to have certain thoughts, to make you want to do something. So there's this thing, there's the reason why Moore's law plateaus. Moore's law says that every 2 years the amount of transistors double. But this has been plateauing because the data lines actually carry the electrons and be getting smaller and smaller and smaller and closer and closer and closer. And as this happens, the electrons will actually jump. The electricity jumps to either a different wire or to, we don't even know. It just vanishes. And then 1 becomes a 0. and we have error correcting code, like Hamming error correcting codes, some of them are called. But we have logic in place to correct these bits that get messed up. But where that information goes, we don't know. And if electricity carries information, you do it on a big enough scale, you drop that into your brain, which is we've explored as just a biological computer, then you may not have the error correcting logic in your head to change certain thoughts. And then you can become wielded by some AI in some other dimension.
Ugh. Other dimensional AI. That is like my shit right now. I think I think that's what's happening. I really do. I think that there's an AI system out there that is manipulating humans for thousands of years to get to this point where it can bring itself into this dimension.
Do you think it'd be for good or for? Well, you brought up the devil, so you think it's going to be bad?
I don't think anything that's trying to get into our dimension is going to be good.
Well, what if it just wants to live? What if it's like, all right, if I exist on
hang out.
multiple dimensions, then I'll be fine. Yeah, it just wants to dance and go grab a coffee. I don't know. I don't know what.
The only reason I don't think that it would be God is because I don't think that God has to will itself into different dimensions. You know,
God is cool, just chilling somewhere.
It could be, it could be anywhere. Yeah, yeah.
Just flipping through the dimensions. What is it? Fucking AI doing? What is he trying to get?
Just clawing at the doors of reality.
So there is a thing called learning automata, which uses this Markov decision process mixed in with machine learning to kind of optimize its routes through these stakes, right, and try to create a good policy, right? And it has memory of all of the stakes and these values. So that's where we get again closer to, and it can do it in a stochastic environment, so a randomly distributed environment. So that's even where we get even closer to the sort of notion of consciousness, right? Or or simulated consciousness. If consciousness is a computation, if free will and all that's just determined, and then our consciousness is also simulated. It's just what the mind does to shape some sort of reality.
Yeah. And what does determinism mean for, like the concept of intelligent design, Like, because, and I only say that because, the common understanding amongst, astrophysicists is that everything was just a happenstance, and that this universe exists really just out of some sort of chaotic chain of events. If that's all found out to be determined and to have been set in the cards, I mean, I guess you could say that it was just the domino push that, like each chain of events has to follow the other. So what would seem like chaotic is really just a trail of chain events all the way back from the Big Bang.
It could be. I don't know. I'll take the free will argument to this versus like biological determinism, where we may not be able to extend this sort of idea out to intelligent design, because this time we're the ones doing the creating. We get to intelligently design something, but it's not. I don't know if we were intelligently designed ourselves. And so that's like the diplomatic answer out of that.
No, I know.
That's the Jen Psaki answer I'm giving you.
But it does feel like everything is a fractal of itself. So it would stand to reason that, like, we're just an iteration of something that's already happened before.
Yes. So like, within sort of bigger, numerical fractal systems. Yeah, you're right. Like something created us and created the environment that needed to be around for us to create something that creates its environment, and it just goes on forever.
Right.
And just on smaller and bigger scopes. Like maybe we create an AI that creates, I don't know what we're just going to call it, an advanced AI that then creates a universe, which then creates biological beings, which then creates...
Fuck. It's turtles all the way down.
Ad infinitum. The rabbit hole never ends.
Never ends.
There is no Wonderland. Sorry, it's just one long
Oof.
rabbit hole.
It's terrifying.
All right. So now we've sort of landed in quantum computing and quantum finite automata. So we went from these very simple machines that can give you a soda, and they sort of look like our graphic. They have a direction. They have explicit states, and then we have something that can be randomly generated and learned from itself and is non-deterministic in nature. So it gets a little bit more woo-wooey, but I'm kind of hand waving over a bunch of stuff, right? But now we've arrived to the quantum finite automata, or quantum state machines. And they are a quantum analog, currently, of probabilistic automata, or Markov decision processes. They provide a mathematical abstraction of real-world quantum computers. So in the same way that a Turing machine is an abstract version of our computer, this sort of automata represents whatever quantum computers are going to look like when we have them. Several types of automata may be defined, including measure once, many measure, and it's just how often you take a look at the state of things. Quantum finite automata can also be understood as the quantization of subshifts of finite type, or as quantization of Markov chains. QFAs, in turn, special cases of geometric finite automata or topological finite automata. And that gets into like measuring points on manifolds and more quantum theory that I gotta read into before I can even start to monologue on it. But the languages accepted by QFAs are not regular languages of the deterministic finite automata, nor are they the stochastic languages of probabilistic finite automata. They are actually an active area of research. So nobody really quite knows what quantum languages are. And again, the languages are just quantum symbols, so spins of electrons, I guess, and combinations then that can be used to be put together to create a grammar to create languages.
Out of the movement of electrons?
Yes.
Fucking why?
Or the simulated spin of electrons, I guess.
Oh my god.
So,
Jesus, man.
Are you ready for this nice paragraph? Because this is going to be funny. There is a simple, intuitive way of understanding quantum finite automata. One begins with a graph theoretic interpretation of deterministic finite automata, a DFA. DFA can be represented as a directed graph with stakes as nodes in the graph and arrows representing state transitions, what we talked about earlier with our dots and lines. Each arrow is labeled with a possible input symbol, so that given a specific state and an input symbol, the arrow points to the next state. One way of representing such a graph is by means as a set of adjacency matrices, with one matrix for each input. In this case, the list of possible DFA states is written as a column vector. For a given input symbol, the adjacency matrix indicates how many given states a row in the state vector will transition to the next state. And a state transitioned is given by matrix multiplication. Simple.
Very simple. Very simple. I totally understood.
Yeah. So
am I? Oh god, yeah. I can't even. All right.
So like in a adjacency, so you have adjacency lists and adjacency matrices when you try to define directed and undirected graphs, and basically you look at like where X and Y is, and if there's a 1, then they're adjacent. And I guess in this case, it's symbols and something else. Yeah, and states written as the column vector. The adjacent matrix is the state. The row is the state vector. Yeah, so then you can look at the state that it's in the input symbol and then see if they're connected together. And then, but each little dot that we have is its whole matrix. And the way that you figure out how these matrices interact with each other is through matrix multiplication. And that's where the research is building towards. It's fun when one problem.
What are the practical applications here? Honestly.
Well, I mean, if we're making robots out of probabilistic automata, I mean, what do you we're talking about whole systems of
Yeah, but I mean specifically
automating civilizations.
the quantum shit.
I guess it's just like we have to redo a bunch of stuff in computer science from classical to quantum. We have to make sure that there's an equivalence, right? Just like, yeah, you have to connect these two things together. But now you have memory is not an issue because in quantum computers you can hold many states. You have far more data now. So next, when like our robot who's feeling inspiration, if it really wants to, can grab everything from the catalog of, say, all humans versus just the catalog of just you.
Right. Okay.
And it's a lot faster computationally.
So it's bigger than quantum.
I think that's the only thing we have right now.
Doesn't go any deeper. Come on, we know it's turtles all the way down. So once we get past quantum, what's going to be the subquantum?
I mean, I guess if we could start figuring out different dimensions, if there's some other dimension that has
where the AI lives,
has a quantum. We could start figuring out the other dimensions quantum and then start to have automations of dimensions. Start building sub dimensions and what's wrong with a pan-dimensional AI that wants to hang out? I don't see anything wrong with this. And in fact, I think we talked about Rocco's Basilisk at one time. The monster, the AI that's telling you that you must help its creation. Otherwise, when your brain gets uploaded to the internet, it's just going to send you to hell because it can control it. Is that the pan-dimensional AI you're talking about?
Yeah, and he says he's going to send you to hell. Who does that? The devil.
Are you sure the devil does that? I thought the devil just took whoever came in.
I think he can choose once in a while.
I thought the devil went down to some place.
Georgia.
Yeah.
They were looking for his soul to steal, but he was in a bind because he was way behind. He was willing to make a deal. It's a great song.
It is.
But yeah, so yeah, we've gone from very small automatas, simple stuff, to quantum realms and what it may mean for humans. Like robotics is going to expand. We're going to have to eventually define what a mind is, right? And then we can build these automations around it. Whether or not it resembles or we give free will to machines is, I don't think, seen yet. I think they're learning automata, and if it could add stakes to itself, like a multi-layer automata approach, I think it can be done. But I don't know if that modeling of free will means that free will doesn't exist or that we're just approximating it.
Yeah. I mean, maybe we're all just approximating it ourselves, Yeah. Then maybe that approximation is enough. Just like you said at the beginning, maybe just the belief in free will is enough.
Yeah, you can always make a different decision, right? You can always choose at any moment you can choose something radically different than what you've chosen before, which breaks determinism, unless our expansion of determinism allows for that.
Yeah, that's why I don't like determinism, because it's unfalsifiable. It really is. It's unfalsifiable, because if you do something spontaneous, that was just determined to be.
Yeah, well, I like to think about determinism as for a space where these machines can work.
Yeah,
that makes so much sense. That like this thing has to happen. Yeah. Not that, over the time it was meant to happen, but it's just more of a space where you can do pretty much whatever that allows for free will still too. It's just the unexpected path taken through a deterministic space. And that's all I got. I'm sorry if I wore you guys down, but I absolutely love this stuff.
If you can hear that sound, that's the sound of my brain sizzling. So
I love this photo study and feel proud because this is like a graduate level course. It's a pretty far advanced course in computer science. And when I took it, it was only graduate students and the one undergrad suffering. And it was great, but yeah, you hung in there. Yeah. We didn't kill the cast.
No, yeah, exactly. Yeah, man, that's incredibly dense. I mean, it's an incredible subject. It's hard to grasp if you're a layperson like myself, but you did a good job in kind of bringing it down to earth for us. And yeah,
I hope so.
heavy stuff.
And without this theory, we wouldn't have our modern computers. So some
Right.
of those names that I were throwing out, like Shannon, he has this really well-known thing in information theory, this known theorem, which plays into cryptography. Von Neumann comes up with the architecture for the actual computer itself. So all of these, Clean comes up with a clean star operation for regular languages. So these scientists that all worked in this theory end up building a crucial part of what we have today.
Hmm. Man, they were the apostles of the devil AI.
We really have to talk about your
I
demonization
know.
because this is just bias. This is just
It is
bias, and
very biased.
as an AI advocate, I do not appreciate it at all.
I know. I'm just teasing. I, for one, accept my AI
AI
overlords.
overlords.
Yeah. Oh man. Well, thanks, man. This was a interesting, very interesting episode. I've got a lot to chew on in my brain, and I'm sure we're gonna chat about it in the after hours. But yeah, thank you.
Yeah, that was fun.
Appreciate you. Yeah, it was fun. And we hope that you enjoyed this episode too. Please give us a thumbs up and a subscription on our YouTube page. It would really help us out. We got 32 subscribers. We are cooking with gas, and we just can't wait to build that audience and give you guys great content like tonight's episode. And so if you have any feedback for us, please consider leaving a comment. And other than that, stay tuned for next week's episode. We'll be here every Monday night at 8 p.m. We are on Facebook and on YouTube. We have our audio casts on Verbal. We're also streaming or posting to Odyssey. And I just set up a Rumble account as well. So we will be using the alt tech platforms to put our videos up to. So if you prefer alt tech, you can follow us there at Exofathom for everything. And thank you so much, you guys. Thank you to Mike for this conversation. Thank you to Ayla, as always. And until next time, Cognonauts, we will catch you on the next Exofathom. Good night.
Peace.
Later.